record on this computer. Okay, so now it's
Yep.
recording. Yeah.
Brilliant.
If you search add to Bluetooth or other device.
Yep.
Bluetooth.
Mm-hmm. I'm not right next to it, but it's literally on the other side of me. It should still pick it up, correct?
Hope it should be something similar to the wireless earphones. So yeah.
Oh, okay. Well,
yeah.
in that case, I might need to move closer to it.
Really? Let's see. Let's see. Probably. Do you have any other devices that are around you so that you can see it? Yeah.
Only my phone.
Only your
so
phone.
Let me see if I can see it.
Because we cannot preclude that there is a device or not. That's your phone.
That's my
so
phone.
Probably that system is a bit too far away from where it is. Yeah. Okay, let's go through that because I'm going to run the commands. Because so what will happen on this is that you first connect to the system.
Yep.
And then you need to choose something called join the virtual network. Oh, there you go. You've already found one. Okay, so
is this?
You just, yes, that is the one. Yes, go that. But maybe this connection is a bit too far. Okay, so if you go for down, yeah.
It thinks it's,
That's the system. Yeah, that is the system. Yeah. But it's somehow recognized as a multimedia. Yeah. It's probably because of.
It thinks it's music.
But if you, let's try to connect to it and then see how it goes.
My headphones drop out. It thinks it's a new source of music.
Ah, right. Okay.
For some reason, it thinks it's an audio connection.
Right. Can we connect to it for now?
Yep.
If you can still hear what I'm saying here after that.
Sorry, Fran.
Okay, so if you just bring that.
The speaker has changed to headphones.
Yeah. And now
let me change my headphones.
Yeah. Now, if you usually you will get a Bluetooth icon in your taskbar.
Not in my taskbar.
Okay, right click on that.
Yep.
And then you should join our personal area network. Yes, do that.
Yep.
And
no matches.
You see, this is something a bit strange. Okay, there you go. So you right click.
Yep.
And connect using
access point.
Yes, please. Okay, so connection successful. Now, I will require you to download a software called PuTTY. P-U-T-T.
Oh, PuTTY.
Yeah,
yep.
PuTTY.
Yep. Yeah. So I think I've already got PuTTY. Do I want to allow my PC to be discoverable by other?
Yes, please. Yes, please. Okay. Yes, please.
I think
it doesn't make a difference. It's just you are currently under the Raspberry Pi within the .logger.
Yeah.
Yeah.
Yeah. Yeah. It's just a SSH to it, right?
That's correct. Yes.
Yeah. It's been a long time since I've used PuTTY.
Okay.
The last,
Mm.
It's just the Amazon.
You don't have to download that one. You have to install. You just download the binary files somewhere.
Oh, where are the binary files? Okay.
So that's the one. Yes. Yes.
Yeah. Okay. Then that's fine.
Okay. So if you got that,
yep.
I'll show you the IP address because I've already connected to it.
Yep.
Serve. Yeah. Okay. So it's 172 dot.
Oops. Sorry.
Yeah. Go ahead.
172 dot.
20 dot.
20 dot.
1.1.
Yep. And what's the port?
It's 22.
Doesn't matter.
Yes. Yes. You just say that is a .logger. Save that as a session.
Yep.
Session. Okay. Save sessions. Yeah. Just .logger, and you can save it. Save it. Yes. Okay. So now, if you click open. Yes. Accepted.
Yep. Accept.
Yeah. Okay. So Pi. Yeah. Sorry. Not the capital. P-U-I.
Yeah.
I forgot the password. If you just enter for now. Okay. The password is UQGEC, Universal
UQGEC.
2019.
Oh, sorry.
Sorry. You have to close it.
It doesn't let you.
If you right, don't do that. Don't stop. Cancel. If you just right click on the bar, the top bar.
Yep.
And you see duplicate session.
Yep. Duplicate session.
Okay. So that's just
the previous session, right?
Yeah. You leave the previous one. Yeah. PI.
So as PI and UQGEC.
2019.
2019.
There you go. You've already in the system. Okay.
Brilliant.
So basically, this is the way how you connect to the system, right?
Yes.
Now, what I'm doing is that I'm different from you. I'm in Brisbane, so I need to use a remote connection to the system. And the way how I manage it is what we call a reverse tunneling. So because I'm going to run some commands and then get you familiarized with the area, so that I will take over the screen share. So you see my screen, okay? Yeah, so if you drop off your screen and then I'll share my screen. Yeah.
No worries.
Does that make sense?
Yeah, no, that makes sense.
Okay, excellent. Well, I really want everyone to know how to use it rather than I give you the fishing net and then you can try to debug yourself rather than I'm doing everything. And but it's just that I do have a lot of like video tutorials like this, but it's very piecewise. I don't really have a kind of crash course that everybody can understand everything straight away. So that's why I was thinking, oh, that's an excellent time. We should do it right now rather than wait too late. Okay.
Yeah,
so,
no, definitely.
Yeah. So now, let me see whether this one. Okay. So now basically I'm in a very new system. So when you go there, it's here. So it's the current location is HomePy, right? So there are some useful commands that I would like to show is ifconfig that shows all the internet connections you have. So this is the modem that I'm able to connect it to the computer. You are actually using Bluetooth to connect to the system. So you remember that this is the IP address. I gave it to you, 172.20.1.1. So you basically, your computer is using that one to connect to it. So ifconfig is always a good command to let you know where the systems are. Okay. Now, the first thing that I normally do is that I will check whether the Raspberry Pi is being connected to the Arduino. So I usually use a command called serial session. So that's basically like, when you open up the Arduino GUI, you've got a TX and RX communication. So this is the online version. This is basically the bash version. So the handshake is basically checking ABC. So ABC. So if I send a command from my Raspberry Pi to Arduino ABC, it is supposed to return ABC. So currently there is something wrong, but usually I just repeat that. Hey, that's kind of very strange. Let me just do a clink. Let me see. There is something wrong. Serial session. ABC. So usually it should end up with ABC exactly. Oh, I see the reason. I probably see the reason.
Is it because I'm connected or?
No. It's not because of that. It's because I have a session that is, I run 2 serial sessions at the same time. I shouldn't do that. Usually what I do, what I use the bash interface is that I will open up something called tmux, because using tmux allows me to have multiple sessions in serial. So I just need to attach to my previous serial session. So you see that when I use tmux ls, that shows I do have a leave connection there, which is very useful. The reason tmux is important is because if you have something running and then later on the SSH is disconnected, the running command is basically terminated, and you don't want to make that happen. So you really want to attach to a window, and you can later on detach the window. So even your computer is switched off, the command is still running. So this is very useful things that I normally do. So I'm now trying to attach to the session that has a name of 0. So I'm using tmax attach session, S-I-O-N, okay, 0. Anyway, so that's basically the command. And now I'm in here. So I've got 2 windows. Can you see my cursor here?
Yes, I can.
You can see, basically, currently I'm in 0 session, which is here. And I have a 1 session here. So if I call 0 session here, I just click, type a lot of zeros. I can use Control B and then N, go to the second session. So that's basically the second serial session I'm running in parallel, which causes the confusions. So now if I do ABC, it is supposed to give me a good ABC. So that's basically a handshake. So what happens in behind is that you've got a Raspberry Pi that sends the command to the Arduino. And then once it's ABC, Arduino returns you a ABC, which means Arduino is basically talking with you. Does that make sense?
Yeah. Why do you have to do it twice? As in, because I can see it sent back AC. For the first
in general,
time, right?
in general, the first time you need to ensure both of them are synchronized. So in some cases, the first one becomes very problematic, but once you bypass that, you will have no problem. You see that now I've got ABC, ABC.
No worries.
Okay. There's one very, very important thing here. You know, a lot of time, Arduino is trying to do something that you don't know, and you have to reset the computer. You reset Arduino. Reset Arduino is literally click the reset button on the Arduino board. But I'm not able to do that right now. I'm actually in Brisbane. So how can I do that? So we write a script. So if you use Control C to finish off this. And then I have another command here. So that's in Python. Pyduino is the library name. It's a Python code. It's a utility, and the .logger v3 test py. So basically run that command. And we have a list of things that you can do. The first one is handshake serial communication. That's literally sending ABC and a return ABC, like what we did exactly. So I just did 1 and no response from Arduino. So always the first time becomes a bit problematic, but usually the second one, you will see that receive ABC response from Arduino, which means the connection is excellent. So the second thing, which is very important, is that if your Arduino somehow is not doing the right thing, what you could do is to reset it. And that's basically number 2. And this reset is exactly the same as you click the button on the physical board. And I tell you, when you do any remote monitoring, this is absolutely important. Because you don't really want to spend $1,000 to click the button there. No, this is definitely not the case. So that's just one of the options we probably can use, but we probably don't need to use it. So so now I need to go back to this serial sessions right now. So I use the exit.
Can I just ask one question? Sorry.
Go ahead.
When you're running the Python, does it matter if you're using Python 3 or Python 2?
I normally just use Python. I don't know what this is, Python 3 or Python 2.
Okay, then that probably doesn't really matter. Then,
well,
because I know
you actually raise a very good question. You know, we've been running Python 2 for a very, very long time, but recently Python 2 is obsolete. So we are forced to move from Python 2 to Python 3. But we are not really trying to do that for the purpose. Instead, we try to, let's say we have a next project and then we use Python 3 exclusively. So there are always some kind of, you know, mixing in between. So I guess that probably this .logger is still running Python 2 at the moment. Okay. So that's where we are. So I go back to the serial session, right? And then we're still here. So usually the first ABC, the first ABC is also working. So that's excellent. Now, the good thing, again, remember, we have a good thing here, which is tmax. I got 2 sessions. This session here right now is the serial communications. And I have another one, which I can swap to by Control B and then N. So that's here. So remember, that's basically the 0, 0, 0, zeros. Now, I will show you a very important Python code that Raspberry Pi will run every single time it boots, because that's basically the way how the data is being measured by Arduino and then send it online. So this is an extremely important script for this start logger. It's stored in Arduino, Python. And then I use V. So I can show you how the command looks like. Now, so it's pretty straightforward. You first import things, whatever required. This is the suction heating time, which is so in millisecond. That means it's actually 6 seconds. And sleep times in seconds. That means how often you need to do the measurement. So basically, we have a.
So that's once an hour.
Yeah, exactly. Yeah, I don't have to explain. Good. Then I've got the field name. Basically, that's the JSON file that all the sensor needs to fill into. You don't have to define it. But
you've already done that.
So we used to use a data platform called Fant, and that really requires you to define that in the first place. So, but later on, these days, the online IoT platform allows you to send what you call it heterogeneous data string. So let's say you got 3 types of sensors. Every time you push, in the past, you have to push 3 sensors at the same time. But this is not good, because sometimes your weather will be sent by once per minute, whereas moisture will requires once per hour. That forces you to send the moisture data, every single minute, which is not really good.
No, because you get a lot of noise.
Exactly. And now what the new system requires is that if you just want to send the weather data, send that, please. And you can leave the rest of the 2 as zeros, or you don't send them. So in that case, you don't really need to create a matrix here, but
that makes sense.
So you're probably familiar with that. And now we've got this. So we got the fan sensors. So this is the fan, which was the previous platform we used to use, and it's obsolete, as we discussed. So you can ignore that for now. But in general, the reason we have the 2 altogether is that I have a redundancy. If you start off having your own online platform, you don't know when the system could somehow be, crash. The system is being crashed or something. So you always send data to 2 separate platform. So if one of them is not working, you could still have the other one. And the other thing we usually do is that we always, these 2 systems are not exactly the same. So I have the original version, and later on I have a better version. And then later on the original version becomes obsolete. So I will wipe it off, and then I create another better version. So now I'm basically upgrading in a stepwise manner. So that's basically the way how I manage the online platform. The port sensor is basically the Arduino port that is equal to COM1, COM2 in Windows. So that's the Linux location. Screen display true is for debug. Save to files true for debug, because if your online system is not working, you can still save it into a CSV file, which you can later on retrieve and then do the analysis. Publish to ThingsBoard. ThingsBoard is the current platform, which is true. Delimiter is basically the separation between each separate file and separate numbers, like CSV is separated by commas. So that's a comma. And here is basically if published to ThingsBoard, it will create the kind of object that will link to the ThingsBoard IP address. So you basically open up that, and then you can shoot data there.
That makes sense.
And then if it's okay, so now we're moving to the big loop, I think. Okay, so basically this one is to allow the Python to be connected to the serial. Bear in mind one thing, very, very important, is that Arduino use a serial, and the serial can only be connected to one device at one time. Let's say you are using your camera right now. If someone is calling you, wants you to share your camera to another app, you wouldn't be able to do it, right? So when you use serial sessions, you really need to ensure that no Python is running in behind, because when you go to the SSH using Bluetooth, the Bluetooth has the system has already got a Python running in background, and if you use serial session, that's going to be in conflict with the existing connection. And the way how I normally check Python code is running is PSAUX, and then the vertical line, grep. Python. So that's the command. So currently you see when I run that, there is only one, that's basically the grep command that has Python, which means currently in the background, there is no Python file running behind. And the Arduino is only used by the serial session that I'm running in behind. Does that make sense? Okay, excellent.
What confuses me a bit is you said the grep function is the only one using Python, but I thought grep was part of bash.
Because command. When I run this command, the command has a keyword called Python. So if you have a Python code running behind, you will end up with two lines. One is the grep processes. The second is actually the Python code. And then if in that case, if you want to do the debug, the first thing is to kill the Python code. So you have to kill. Usually you need to find out the ID number. So that's the ID number. You kill that process. So that when you do the serial session, you know all the result will return back to the serial session, not to the Python code. Does that make sense now?
That makes sense.
Excellent. Oh, I so appreciate that you do have some bash background, because you know, if I talk to a Windows user, it's completely alien.
Bash makes so much more sense than Windows, to be honest. Like, I hate MS-DOS or like command line. It's just, it's messy. It's annoying.
And for me, I start to learn that when I feel I have to, because you know we discussed previously that I understand you running some finite element code to look at the brain procedures.
I'm not doing that anymore.
Anyway, but you know, people who tends to run large simulations start appreciating these kind of systems.
I had to connect to a supercomputer. It makes it so much easier, like to just SSH and file transfer that way rather than any other way through Windows.
Cool.
You know, even to have a secure connection, it's just so much easier.
Okay, that's beautiful. Well, in general, I'm so glad that you can basically listen to these details. And I mean, to me, it's just a way to make work much more straightforward. And we can basically, you know, return with some high-level questions. Okay, so now I still go back to where we used to be, and let me see. Okay, so now we're here. So basically, the try while true is basically an endless loop. It's an endless loop. So it will first connect it to the Arduino through a serial connection. And then it will sleep for 5 seconds. And the sleep is very important, because usually, if you look at these lines for a computer to run it, it's pretty much like take milliseconds, right? And in that case, what the system will do is that they will connect to the serial and immediately send a TX message to Arduino, and Arduino will feel overwhelmed. So it's important to sleep for a few seconds so that Arduino will process what's been done before. And then you send another command.
So I've had that error before.
The other similarity is that if you use what we call batch system to you know, to send large number of simulations, every single batch submit will have a sleep in between, so that you don't basically send 1,000 simulations by 1 second and the system will feel overwhelmed. That's exactly the reason behind it. So it has the time now local, sequence since epoch. You know, this is some kind of things that we tend to do. We try to make the variables somehow like you can read. So try to make variables as long as possible. So that next time when you look at it, you know exactly what does it mean, right?
Yeah, exactly. Because you don't have to comment. I can see there's not many comments, and that's because it's in the text.
Exactly. Yeah. And then you print the time. If save to file, you save the time to file. Okay. Now this is the critical things. I'll explain what happens here. So now we need to send a string to Arduino, and Arduino will read the string and then do exactly what it's supposed to do. So the string is the string is basically the commands, and the commands tell exactly what Arduino will do. So in this command, it will basically do the system voltage. Right, the voltage is being achieved by reading from an analog. So basically, the command number 1 is said this is an analog reading. The channel is channel 15. Now, when you do an analog measurement, the circuit that measures the voltage is not permanently connected to the power. We only power the sensor or the element when we are doing the measurement. So that means that we need to power the circuit that requires you to do a voltage reading. So the power line is controlled by pin 9. Right. Okay. But this is already done internally in the PCB, so you don't need to worry about it. Point 3 here means that once it's been connected, you basically measure 3 times. Interval milliseconds means that in between this measurement, sleep for 200 milliseconds. And
what does it say, millimeters?
Sorry, milliseconds.
No, I mean like the...
milliseconds, sorry. Milliseconds.
That's all right.
Milliseconds. And then debug 1 means that you give a bit details to the system. You basically give what you are trying to do rather than just give the results. So now what I can do, I can copy the whole line. Okay. And then I can move to the another tab, which has got a command serial. Again, the command for me to do it is Control B, Control and B, and then you click in. Now I'm in this session, right? And then I can right click simply by right click.
Right? It's a paste.
Which is a paste. You see, it ends up with 771, which is basically the voltage. And if you run the same command again, you probably get the same result because it's a wall power. That's exactly pretty much the same. And if you just try to change the debug from 1 to 0, let's say, you just end up with the result you want.
771, that's
771. Okay, so the way to understand 771 is that this is a 5-volt Arduino. So 1023 is 5. So if you need to change that to the voltage, you have to divide that by let me think about it. Divided by 1023 times 5. So that's basically the conversions. Oh, okay. Sorry. There's another things here. I will explain to you. I think you are very interested in. First of all, is that the system runs by 5 volt. The Arduino runs by 5 volt. And the connection is 12 volt. And if you try to connect try to measure a voltage 12 volt through Arduino, basically it's burned straight away. So the way how I measure it is to use a voltage divider. And the voltage divider is basically a third of the power. So so roughly would be, I think once you measure this voltage, you need to multiply that by 3. That is basically the power.
No, that makes
We've already
sense.
done all the internal things, so you don't need to worry about it.
So, and that makes sense.
And if you've been looking at the online the weather station in the mine, it's been running there for 2 years, and you see the daily fluctuations. That's basically how it's reflected to the solar conditions there. It's just amazing that we haven't done any services and it's still been working. Usually we ask clients to do a service once per year, and it seems to be very healthy, so we don't need to worry about it. So does that make sense?
That makes sense.
It's basically the way how we communicate with the system. And now I basically move to another tab, back to here. So what does this later on this here means is that you've got a Arduino flash input. That means you need to ensure all the input, all the returns from Arduino being completed.
Yeah.
So, it ends up with a long string, which may take time. You don't really want to retrieve the string when the data is continuously sending, right? You need to ensure the last line from the Arduino already being sent. So that's basically the reason behind it. And then you can read it. So that's the MSG read line.
Yep.
Now, we need to, basically, the rest of them is basically parsing the data. So the current rate first is to split all the information with the delimiter, which is a comma. And then it ends up with an array. And the voltage is basically change everything into a float and just get the very last one. And remember, the whole string, the very last one is the piece of important information here, right? So the rest is basically parsing. And I will show you that one thing is very important is always try. When you do all the runnings, it might end up with a string that is not something that you would like to.
So
and
you
if
need
the
to error
parsing
correct.
is wrong, the Python code will stop. And this is something you don't want.
No.
So then you can say, oh, let's ignore that. Let's do it another time. But one thing which is also important is that you definitely need to define something that is helping you to see this is a critical error, because maybe all the sensors will tell you try, and you keep trying and keep getting the wrong data. And then that's something that you don't really make it happen. And one of the things that we ask them to do, system to do, is to reboot every day. So that, and the reboot, this reboot is the same as you pull out the power from the board. Not really just do a soft reboot. And we feel this is extremely important, particularly, when you have a Raspberry Pi, it's a computer. And the computer might be running, like booting, but the booting failed. And what if the boot failed? You probably have to pull out the plug and push it back in.
Because there's no way to get back to the boot screen.
And if we don't really have this kind of cold start, I probably have to buy a ticket to go there to fix the problem. And this is enormous. So we've already, in the software wise, made the function so that you can reboot. You can code reboot the Raspberry Pi as well. So you ensure this is definitely being done. So basically, I'm just showing you how that is being done. And if the result is not correct, then you just print something, say system voltage reading field error. But this field does not terminate the Python code.
No, it just tells you what's going on.
Exactly.
If it errors,
Okay. The second thing is usually we do the enclosure.
Oh, that's
so if
for,
you look,
that's for humidity and temperature.
The humidity and temperature inside the enclosure. So
because that's just a sensor that connects us to the Arduino, right?
Exactly, yes. And just give you a bit of history. So if you used to buy a Campbell Scientific logger, it comes with a stickers, and then you use the color band to tell what is the humidity. I think this is out of date.
That's so, very out of date.
So in that case, we usually just put in a humidity sensor. So if the humidity in the enclosure is more than 90 degrees, that means we need to change the desiccant. But for this kind of lab setup, you don't really need to do that. So again, the reading is pretty straightforward. You see, this is the type of sensor, DHT22. And this is the digital port that connects to the sensor. The power is basically
port number 2.
Number 2, and that's basically inbuilt into the PCB. Don't need to worry about it. Do 2 measurements. Okay, so the dummies here is very important. So the DHT2 sensors always have the first data being problematic. You don't really want that data being averaged within the 2 points. So you basically get rid of the first one and then measure the second and third.
So you have a burn-in kind of thing.
Exactly. And intervals is basically the milliseconds in between each measurement and debug one. So if I do this line, I want to show you. So again, I use Control and B and right click. And then you end up with 2 values. This is the temperature. This is the humidity. Okay. So now I move back. Control B and again. Now, flash input, read line, remember the two, split all the things into separate arrays, and you
then
get
grab
the
the
last two.
second last and last. Yep.
Exactly. Yes.
Yep.
Okay, so this is easy. Now, moisture sensors. This is important. Now we're coming to the main things.
Yep.
So all the moisture sensor we are running right now using a protocol called SDA12. And majority of the environmental sensor actually use that. And luckily enough, someone was generous enough to have the SDA12 incorporated. Yeah, open source. Yeah. But we actually have to change a lot, which already done.
Okay.
Yeah, it takes a lot of time to integrate it. And our effort is not trying to, basically we're like a glue. We glue all those kind of functions into one what they call library, so that when you burn it, you use the separate command to be able to get that functionality. That's exactly what we did. So this is quite straightforward as well. So you've got SDA12, digital channels 53, the sensor to be powered is 46.
46,
yeah. And then default command is to read the data, and then you have a debug. Yeah. So that's basically the moisture one. So I just select all everything. Control B, and I go to the another tab, right click, and then I shoot the commands. And you'll be able to see something like, it might take a bit of time. So what will happen here is that, I'll give you some background about SDA12. I think this is very important. So we've already got the results. So I know this is a Campbell Scientific sensor.
Yeah.
Okay. SDA12 is a very common used protocol for environmental sensors, and the majority of them sensors in geotechnical and hydrogeology use this kind of protocol. And this sensor this is a digital protocol, which means it sends the strings. And the other good thing is that one digital channel can connect to multiple sensors. So every sensor would have their own IP address. The IP address is usually 1 to 10. 1 to 9, so 0 to 9, or A, B, C, D, E, F, G. So from here,
so you can have 10 for each. So 10 sensors for each data stream. If you've got, unless there's another way to differentiate between.
Usually more than that, because the alphabetic goes from A to Z. That's 26. And then numbers are, so it's 36. And also you've got capital ones as well. So it's one string has got more than 50 sensors. But again, I normally don't put all the sensors into one digital channel, because one of the things we find that not very commonly taking place, but it's possible, is that one of the sensor gets short-circuited. And if that's the case, then all the sensors in that digital channel has to be disabled, because if you don't do that, the rest of the system wouldn't work. So this also shows the importance of having the power separately. Because let's say if you have a data logger that has 100 sensors, and one of the sensors is short-circuited, you basically
you lose all of them.
Exactly, and you still have got a successful project at the end of the day. And
no, that makes sense.
So here, what they does is that they find out a Campbell Scientific sensor, and the sensor, the number of sensors connected to the digital pin is basically only one sensor in that digital pin. And then you've got, I think the D here is basically the sensor channel, if I remember correctly. But there are always, we just need to repeat this command so that we know this one, which one is actually the sensor ID. But you've got several things. So the sensor is basically not in the soil, which give you zeros. The other one is EC, and here is the temperature. So again, the three of them is the most important values that we need to send it online.
So this is pretty much how you ping it, right? How you know it's working is you'll just send the command, and if it gives back.
Exactly.
Okay, that makes
so
sense.
Let's just repeat that, and then we can see how many sensors are working, right? So usually for me, when I do that, which might not be a good way, but I usually do that, is that if this sensor is working, I'll just put this one here close to it. And then I normally also add the date
Yeah.
So that we know this is being done by what date.
Yeah, no,
So,
that makes sense.
Yeah, so that's basically moisture sensor 1.
Uh,
and you do, yeah, go ahead.
Sorry, I do have one more question.
Yeah, go ahead.
Is moisture sensor 1 based upon the port you put it in, or is it based upon the actual sensor? So is it based upon where let's say I plug in something to moisture sensor 1, like the location on the board.
Yeah.
Is the name moisture sensor 1 based upon the actual sensor itself? Does the sensor have its own ID, or is it the port?
It's the port.
Okay, that makes it so much easier. Yeah. That's easy.
Yeah, so that's why I would recommend to tag each sensor with a specific port. So that sensor always go to that port.
Yeah, no, that makes sense.
Steven,
that makes it easy for us.
We've already done a automatic stream match to be able to tell which type of sensor it is.
Yeah.
But this kind of differentiation is very fresh. I mean, the differences is basically to check the strings, but maybe some of the sensor is not following the SDA12 protocol, and that causes the problems. So in that case, once we did this one successful, we basically attach to the port and plug and go. That's it. So so that's where we are now. So the rest of them is pretty much the same thing. You see, this is the bit that we did that will tell different types of sensors, but it's basically the string match.
Yeah, and the Campbell has a different protocol, what do you call it, data readout than the other one, correct?
Exactly. So we attempt to do it, but it may be not perfect, but you see our attempt anyway. So that's
sense.
Basically one of the sensors working.
And then this is just copied for the rest, is that correct?
Yes. Okay, but let's go through that, because we can see at least some of the sensors are correctly soldered, or some of them are not. So, but we can make it very quick now. So I copied the whole line, Control B, N, and then right click.
But is this an example where they're using the same power?
Yes, they use the same power. Yes.
Yeah.
Okay. So the reason this one is relatively slow is that they basically check all the addresses. They basically do a for loop, say 0, 1, 2, 3, A, B, C, D, E, and find out whether there's any moisture sensor here. So again, one sensor, the address is 6. I think this is a what they call meter string. So that's a relatively new sensor with the extension cable. Okay, so this is a little bit tricky. You see, you've got a large value, 1,000 or something. This is basically a dielectrical permittivity of the sensor at default. And once it's around 1800, it means that it's in the air. Once it's about 3,000, it means it's saturated by water. So in general, all the sensor company wouldn't give you a calibrations. That's because the soil medium has a background reading that is always different. So if it's full of minerals, that gives you background reading. And if the solution has more salts rather than fresh, the highest value is different as well. So they give you a kind of empirical linear line, but for tailings, whether that's reliable or not, we don't really know. But
so how do you calibrate them?
We've already sent you some videos before, remember?
Okay.
Yeah. So, but in general, if you don't really want to calibrate, like you want to bypass that, and you are doing a drying test, like from completely wet to dry, you could assume that the wetted and driest points, and use a linear line to get between the two. But I can tell you, it's definitely not a linear curve. Definitely.
No.
But that's always a good start.
It's like it's like an S curve,
well, I do have a document to show you that it's basically like it's what they call 2-point measurement. So you got 3 factors here. One is the highest value. The second is lowest value. And you consider this as a string. The third one is basically at the middle point to pull them off from the middle line. So once I pull, it becomes like a curved. Does that make sense? So that's why we call 3 points. Like you try to pull it off from a diagonal line. So
so you end up like with like a Bezier kind of thing, like a spline-ish.
Exactly. So I tend to use that value always as an empirical.
Makes sense. Makes sense.
And I remember that value is about 1.5. So I mean a bit offset as compared to a linear line. So this is definitely the temperature. You see the two values are pretty close. This is EC, electrical conductivity. So if it's in the air, that gives you a 0. So that's basically the meter 3 sensor. So meter 3 sensor actually is a very, very popular sensor right now. And a lot of people use it. The other thing also bear in mind is that SDR12 has a longest cable length of 60 meters. So you couldn't go further than that.
Perfect.
Also, if you want to know if you feel a bit more, it use a baud rate of 1,200.
What was it?
Baud rate. You remember when you use Arduino, you tend to use 9,600. So low baud rate means that the data is pretty secure, but the transmission rate is very, very low. So the number 2 basically works. I can copy this in below the script so that we know this one is being tested. So I have this and then okay, so that number 2 is down. We don't need to go through that anymore.
No, that makes
basically
sense.
Parsing.
Same for number 3 and all the rest.
Let's do that so that we know exactly how many is being down and which one is not working as something we need to check. Control B N, right click, and that will tell probably whether that sensor works or not.
Should hopefully.
There you go.
Brilliant.
So this is a decagon sensor. So that's the sensor that doesn't have a connection, extensions. So this one, this reading is becoming a bit strange again. So I think one of them is the electrical permittivity, and one of them is EC. This is the temperature. You see the base value is different from the meter 3. I tell you that these 2 sensors coming from the same company.
Really?
But yes. But later on, once it's been taken over by meter, they basically rebranded. These offset values becoming different. And again, you have to, do all the calibrations. But they have a manual to tell you the empirical, and it's your own choice whether you trust it or not. But that's
This has a 1 instead of a 0 at the end as well.
Can you say it again?
At the end, the very end,
that could be EC.
But the EC here is 1, whereas the others have EC of 0.
I think the EC unit is micro Siemens per centimeter. So if it's C line, it's actually 60,000 or something. So it's huge. So that basically tells it's nothing.
That's my noise basically.
Okay, so I'll just copy this one again back to.
I'll be back in 1 second. Just got to see how we're doing. We're also trying to get this suction done as well.
Okay, cool.
Just be 1 sec, Chen Ming.
Yeah, sure. All good. All good.
Sorry, I might have to head off in a sec because we got 2 of us trying to do the soldering.
Right. Okay. Well, probably we can stop for now, and I can repeat the rest. And you pretty much can do it rest.
No, I can do the rest of the moisture. The suction is the suction the same? It's just going to be a different command.
It's a bit different. I'll show you how it works. And so far we haven't figured out a way to be able to I'll show you the sensors, and then you understand how why it's been different. Okay, so here is the command. Fred, yes, Fred. Why?
Is Fred's the
Fred's
the protocol?
No, not really. This sensor basically uses what we call, this is called the Fredland sensor, because it uses the heat
Murray
dissipation.
Fredland.
Yeah. So we just use Fred instead. Okay. The reason that the suction sensor is a little bit tricky is because every single sensor has got that type of ID, and you need to find it. Yeah, the way how we find it is use a command called search. Yeah, so the key thing here is digital in and sensor power. So 18 and 27. So usually we have to say, let me see, I'm somehow getting a bit problematic.
Yeah. 2 minutes.
Just two more minutes, and then we're pretty much finished here. Yeah. Oh, it's here. Okay. So that's basically the command.
Yep.
So what this command here do is that you search from the channel 18 using power 27.
Yes.
And then
are all the suctions plugged into power 27, or are they split?
Not really, not really. I'll show you. So basically, when I push that command, you see that this basically tells you there are two sensors in that digital ports.
Which is correct,
Yeah, which is correct. And then when you find out the sensor ID, you need to tie that sensor with a specific heating element, because the sensor has got two functions. One is to heat the sensor. The second is to measure the temperature, right?
Yes.
Which is the reason why when you look at the command here, you've got a Fred ID, digital in, sensor power, and heating power.
Heating power.
Yeah, exactly. Yeah. And then, well, I think I've got the full command here. I'll show you. 2 minutes, and then we're done.
Yeah, that's all right.
Yeah. Let me see whether I have.
Is that because that ID, that's hexadecimal, what it gave you? What's the actual ID?
That is the sensor in-building temperature sensor ID.
Okay.
Yeah, so every temperature sensor has their specific temperature sensor ID. So I can't change it. Yeah.
Yeah, that makes sense.
Yeah. But unfortunately, I don't really have it here. Yeah, I can show you one command. Maybe I just quickly. I just quickly change this a little bit so that I show you how the result looks like. So let's say heating for 5 seconds. And the interval is 5.
Yeah.
Okay. Let's do that and see how the result looks like. Okay. Now you see, it's basically not working. That just means that the sensor ID is not right. But this is probably the ID. You see that the ID I put it in is not in the list. And of course, you wouldn't be able to get the results.
Yeah, because I can see it's different from, okay, I got
you. So then let me see whether probably it's already somewhere. Let me search the sensor 2 and 3, 4, 5. No, okay, so that's why. Right. Anyway, so basically, this is the way how I check every sensor work. And then the thing that I need to change, in particular for the suction sensor, is that I need to associate
the ID with that
by the specific ID. And again, if you just always use that sensor into that ID, I don't have to do anything in the
that makes sense. But associating a sensor, I'd have to do it one by one, wouldn't I? I'd have to plug them in, then do a test, and then go, that's that, and then plug a new one in. That way I can differentiate. Okay, makes sense.
Exactly. And then once it's done, it's completely
No, finished. That makes sense.
And so some background script that I did for this script is that in the past when we do a project, you never pull out the sensor because it's supposed to be in the field for 2 years. And this time we need to ensure we process the no sensor connection correctly so that if there is no sensor in that channel, the loop is still running. So that's basically the background thing we did. Anyway, so I think I hope that really is helpful, and you can play with it.
It's extremely helpful. Yes.
Okay, you can play with it. Don't worry, everything is backed up. And there are some background script running. So if you don't cut the internet, I can help you.
Okay, no worries. You got some file safes.
Yeah. Otherwise, you know, it's becoming a bit tricky. Or I can send you another SD card just if you everything, you know, runs by now.
No worries.
So what I'll do afterwards is that I'll give you a list of sensors that works and that is not working, and then then you're basically free to go.
No worries.
I think we could also do another tutorial later on to show you how to work with the online platform
to make a super user, to get super user access.
I haven't give you a access. It's a customer. I need to give you a super user privilege. On that. And
no, that sounds good.
Okay.
Brilliant.
Yeah.
Thanks, Shenming.
Yeah. Thanks, Stephen. All right.
All good. I'll talk to you later.
See you.
Try and enjoy your lockdown.
Well, we'll be fine. All right. Cool.
No worries.
Bye.
Bye.